Okay, the next machine you need to have is some general purpose drill mill. This is like a very simple machine. Usually it's convenient to set it up with a milling vise and a drilling vise at the same time, because the drilling vise is quick acting and of course saves a lot of time, but it's not stiff enough for milling. It will loosen, so don't try to do milling in it, so you need a separate vise for milling, but there's plenty of room here for both. Now this is a bit modified. It has these spring-loaded stops, so you don't need spacers. It will stop by itself, but that's not so important. You can always put some spacers inside. Now there's a few other modifications here which are worthwhile. Is first of all, these mills come with a depth adjustment which takes forever to turn. So the first thing you do is you drill a hole through the nut at a slight angle. So you can turn the nut to position, but if you want to move it a lot, you can just tilt it and slide it. And so you slide it and then you just turn it. Okay? So this saves a lot of time. Now, the one thing which is a must on all these machines, if they come with a belt drive unit with a step pulley, it's a must not to use that and put what's called a VFD, or a variable speed drive, because that is so much simpler and it's so cheap that it's a waste of time to change the speed any other way. So for example, if I look at this, I can change the speed over a very, very wide range without having to touch the pulleys. So that's very, very important, especially if you want to do tapping on the same machine. So you want to lower the speed and so on. Readout, of course, which is pretty standard today. A very, very useful accessory for a machine like this, which unfortunately you can't buy, don't ask me why, is some kind of a laser center finder, and all what it is a head from a laser pointer. The lens is moved a little bit to focus about here, and a battery, and it's designed to clip on the chuck or clip straight here on the shank in case you use collets. So this sits like this, and what it does, it gives you a circle of light, and the nice thing about it that the center of this circle is actually the axis. So if I want to line up the machine with a feature, I want to drill on this mark. Say I have this mark here and I want to line it up. It's very easy to line it up. Okay, if I want to drill at the center of this, I can make the spot much bigger until I find the center, and then I find the center this way. And it's particularly useful if you want to line up, to drill, to line up with a hole or a pin. So say for example, if I had a pin and I had to drill exactly in the middle, obviously I'll use a lathe, but if this was square, let's say, or some other shape, and I want to line up the spindle with the middle of this boss, what I would do is I would just go like this, let's see, and it forms a ring around it, and that ring position is very, very sensitive to alignment. So if I go a bit up here, you can see if I'm just misaligned, the ring will move, so you can easily line up things to 50 micron in 1 second. And let's say you have something with a hole in it, and you can see how it's very sensitive, and you adjust it until the ring of light is horizontal, then you're centered to the hole. And the same thing if you want to cross drill, if you wanted to drill exactly in the middle, you would line it up like this until the light just is broken at both ends at the same time. So you adjust it like this, and then the light stops when it hits the diameter, so when you get a V on both sides, it's centered. So that's a very simple thing, which, as I said, it gives you about 50 micron with no trouble, but you have to make it yourself. Obviously it's made on the water jet, so it's very easy to make. Okay, good. So this is all what you need here. One other item, it is desirable to standardize on one collet size for all your tooling, so you don't forever change collets when you change tooling. So this is standardized on 3/4 inch collet. So everything which goes here, like if you look at the chuck or the boring bars or all the accessories, they all have the same shank. Okay, so and even if you do some drilling, you try some milling, you try to pick some mills which also have the same shank, so you can switch instantly from milling to drilling. As you know, you cannot use milling cutters in a chuck, it's not rigid enough, but this way you can switch from milling to drilling and from boring and other things. It all sits in the same collet size. So you have to add this wheel on top, so you don't need to look for wrenches. Okay, again, it's just 1 minute on the water jet. So, okay, so then you lock it and you're done. And obviously you want a chuck like this, not a key chuck, because the key chuck, you know, you always have to look for the key and so on, and these chucks are more accurate too. You just do like this. These chucks are self-tightening, so even if you didn't tighten them, as it drills, it will tighten itself. So you just do like this, it's locked, that's all, and you drill, and when you finish drilling, you just do like this and take the drill out. Okay, so it saves a lot of time. Okay, so this is a chuck, and that's it. The only disadvantage of keyless chuck is that the same way it's self-tightening, self-locking, if you run it in reverse, it's self-opening. So if you want to tap, you have to tighten it real hard, otherwise when you reverse the tap, the chuck will open. Okay, so there's lots of material how to use a lathe, so we're not going to get into it at all, but there's just two things I wanted to point out. Almost every lathe you look at has a 3-jaw chuck, what's called a 3-jaw universal, where the jaws move together. It turns out that for R&D work, and for actually most precision work, it's a mistake. It's much better to put up on the lathe a 4-jaw chuck. Now, the reason why people don't think of a 4-jaw chuck, they only think of a 3-jaw chuck, is because a lot of times in regular shops you have to handle hexagonal work, like to make, say, fittings. It's all made from hexagonal stock, and most people don't realize that you can grip a hex stock in a 4-jaw chuck without run out, for example, because there are 4 points around the hex which form a square. So if I put it in like this, say I can grip it without run out. Okay? Now, if you have a 4-jaw chuck, you can grip square parts, which is very, very useful. And if you grip round parts with a thin wall, because you're pushing at 4 points instead of 3 points, there's much less distortion. So I highly recommend that you equip all your lathes with a 4-jaw chuck. So a very useful thing to have on a lathe is to mount a video camera, which you can see the tool tip. For example, if I had to do threading on some complicated part, it's much easier to see it on the video camera when I approach the part, and I can line it up. And basically this camera is about 100x magnification, so I can easily see a few micron error here on the camera. The cheapest way to get these cameras and monitors is to buy a kit which is called a rear view camera for cars, which comes with a display in the camera, and you just have to put in a different housing and also change the distance of the lens in order to get a different magnification. And the whole thing is about $100, and you can put it not just on a lathe but on many other machine tools.